Number 7, letter A. Repeat the problem 2 problems prior, but for the second leg, you walk 20 meters in a direction of 40 degrees north of east. Okay, blah, 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 blah. So just to give you a little context, this is talking about number 5. Let's write down that so basically the first leg, I'm going to write it here. So the first leg, you're going to walk 12, it says 12.0 meters at, what was it, 20 degrees, I think it was west of north. And now for the second leg, you're going to walk, it's saying 20.0 meters at 40 degrees north of east. Okay, so remember the strategy. And what we're still trying to do is we are trying to solve for the resultant vector. We want to know the magnitude, and we want to know the angle of that resultant vector with its directional components. Okay, so remember that in order to do so, what we want to do is we want to create our component table that consists of well, I don't have to draw the line down there, but it consists of x and y's. And what we want to do is we want to find the components of this vector, plug it in, components of this vector, plug it in, add them together, and then that will give us our resultant vector. Okay, so I'm looking to create my component table. All right, so first let's take a look at the first vector. So simply draw a coordinate system, then draw the vector in it. So it says we're going to draw a vector at 20 degrees west of north. So that should look somewhere in this vicinity. This is 20 degrees west of north. And the vector has a magnitude of 12.0. So what would be its components? Meaning what would be its y component and what would, well, I just drew the x, but what would be its y and x component? So it looks like this would be the y component here. This is positive y. And this would be the x component. And that's a negative value because it's over to the left. Remember that this is the positive x, this is the positive y, right? This is the negative x, and this is the negative y. Okay, so first let's look at solving for, it doesn't matter which one we do first. First, let's solve the x. Remember, you know the hypotenuse, you know the angle, and we're looking for the side opposite of the angle. So that means you would be using sine for this. So sine of theta, and I have the formulas over on the right-hand side in case you may have forgotten them. So sine of theta is equal to the opposite side over the hypotenuse. So the sine of our angle here is 20. And we're looking for the negative x component, and the hypotenuse of this was 12. So let's solve. So let's do sine of 20. Sine of 20 multiplied by, it's just a cross multiplication, multiplied by 12. So negative x will equal 4.1. Remember to throw the negative on over there. Right, so my x component here is going to be negative 4.1. So that's going to be, I'll call this for my vector 1, my first vector. Okay, its components are negative 4.1, hold on one second, negative 4.1 meters for the x component. Now let's look at the y component of that vector. So go back to the picture on the left. Here's the y component. Remember, I know the hypotenuse, I know the angle, and now I'm looking for the side adjacent to the angle. So that means I would be looking to use a cosine function now. So cosine of theta is equal to the adjacent side over the hypotenuse. So the cosine of my angle of 20 is equal to now the positive y value over 12. So simply just plug this into the calculator. So cosine of 20 multiplied by 12. So this works out to be, and 2 sig figs, this works out to be 11 meters. Okay, wonderful. So this is now the y component of vector 1. So I would plug in my 11 meters here. Okay, and let me just box in the x component of vector 1. Okay, now let's do this for vector number 2. All right, so v2 now, and this is my second vector here. So let's draw a completely new coordinate system. I'm going to draw it down here, and let's draw in the vector how it's being described to me here. So it says 40 degrees north of east. So here's east. So 40 degrees north of that is going to be somewhere in here. Right? This is going to be the 40. And the magnitude of it is 20. So that's the length. So what would be the components of this vector? So it looks like it has a positive x component and a positive y component. So positive x and positive y. Which one do you want to solve for first? I'm going to do the x one. Doesn't matter which we do. So to solve for the x component, remember, I know the hypotenuse, I know the angle, and now I'm looking for the side adjacent to that angle. So it sounds like I'm going to be using cosine. So cosine, again, cosine of theta is equal to the adjacent side over the hypotenuse. Cosine of 40 degrees in this problem now is going to be equal to the positive x value over 20. So the positive x value will now be, simply take cosine of 40 and multiply it by 20. 2 sig figs, so we're going to use 15. Okay, so that's in meters, right? So that is the x component of my vector 2. So let's plug that into the table, 15 meters. Great. Now let's do the y component. All right, so here's the y component in the picture. Remember, we know the hypotenuse, we know the angle, and now we're looking for the side opposite of the angle. So that would be a sine calculation, right? Sine of theta is equal to the opposite side over the hypotenuse. So sine of 40 is equal to positive y over the 20. So the positive y value will be positive. So sine of 40 times 20. And this works out to 13. I'm going to round to 2 sig figs again. So 13 meters. So this value gets plugged in to the table. So 13 meters. Those are all the vectors, right? And now from here I can solve for the resultant vector. How do we do that? So simply sum now all of the components together. But you're only summing x's with x's and y's with y's. You don't sum x and y literally together. Okay, just sum all the x's separately and then sum all the y's separately. So now my resultant vector here would be, I would do 15, right? 15 minus 4.1. I know it's 10.9, but technically we have 2 sig figs, so I'm going to write 11 meters. And now the add up the y column, right? So when I add 13 and 11, right, I get 24 meters. Now these are the sum components of the resultant. Okay, this value what we did was we summed all the x's. And this one, we summed all the y's. Now take a look on the right-hand side. I have a nice formula here that tells us how to calculate our resultant vector by using this component table. So all I need to do now to find the resultant vector is to simply take the square root of all the summed x values squared and added to all the summed y values squared. So all we have to do is simply plug in these numbers. Here's my x value. So that's going to go in here. So square root now of 11 squared plus, here's my y value. Let's plug that in. We'll take a little round trip there. And now that's going to be 24 squared. So my resultant vector will now be square root of 11 squared plus 24 squared. So it works out to 26.4, so we're just going to keep it at 26. 26 meters, that's the magnitude of the resultant. Now, how do we calculate the theta? Because remember, we just, on the left-hand side now of the screen, I calculated the resultant. Now I need to calculate my theta. So I have a nice little formula here at the bottom to calculate your theta. Okay, simply just plug in the sum of the y's and divide it by sum of the x's and the absolute values of both. Okay, so I'm going to do that upper left-hand corner. So tangent of the resultant angle is equal to the absolute value of the sum of all the y's divided by the absolute value of the sum of all the x's. So what was the Sum of all the y's, 24, right? Sum of all the x's, 11. And they're both positive, so I don't really need to do anything there. So now do this. Take 24 divided by 11, and then do the inverse tangent of that, or second tan of that number. So second tan of 2.2, because we got to round to 2 sig figs. So the theta value now is 65, we'll round to 66. That's in terms of degrees. Okay, now we're almost done. We just now have to say, well, north of east or south of west or whatever. So how do we do this? So I think from this point, it would be good and much easier to now actually draw the resultant vector. So remember, I'm going to box it right in the middle of the screen. These are the components. And actually, let me do it in a different color. Okay. These are the components right here of the resultant vector. This value is the x component. This value is the y component. Okay. So draw a set of axes. I'm going to draw it in the top of the page. Here's just a set of axes. Now, start with your x value. It says that the x component of the resultant is positive 11. So, positive x is this way, and it has a value of 11. Then from this particular point, do your y. And now it says that you have a positive y value of 24. So that means go on up. 24 units. So that looks about accurate. And now your resultant vector will literally be the distance, the straight line distance from the start to the end. So this is your resultant. And we found that resultant to have a magnitude of 26, which makes sense given the picture. We also found that this angle here should be 66. And that makes sense. Now, all I have to do is state south of west, north of east, blah, blah, blah. So this angle is being measured relative to the east axis, right? And it's in the northern direction. So I would be using the terms north of east. So let me fully write the answer. Okay. The magnitude and direction of the resultant vector is 26 meters at 66 degrees north of east. This would now fully describe the magnitude and the complete direction of the resultant vector. Thanks, guys, for tuning in. Hope this helped. And if you need more practice, the problems prior are all variations of this technique. Thanks for tuning in. Please remember to subscribe. Until next time.